these exponential equations algebraically, and we do it with logs. We said that we want to isolate the value first, isolate the base and the exponent first. Okay? In the examples we've seen so far, pretty much those bases and exponents have been isolated. And then what we do is we take the log of both sides. Again, we talked about how you can take the natural log of both sides, the log base 10, or we can also take the natural log of both sides. Or you can also convert it into a log with a base of 19. If you are taking the log of both sides, that x can move in front then, and then you're solving with division, because this becomes a multiplication problem. The only time I personally use the natural log to take both sides is if I have a base of e to start. Okay? So this is where I would personally use a natural log of both sides. However, if you want to take the natural log of both sides for this one too, you could. Okay? So let's look at checkpoint 3. It's 7 times e to the 2x, and then minus 5 equals 58. So this one has a little bit more going on because we're not just given the base and the exponent right away. So this is where we really want to follow our steps from yesterday. So we're going to first use PEMDAS backwards to isolate that base and the exponent. So we undo addition subtraction first. So I have a minus 5 here to start. We're going to undo the minus 5 by adding 5. So we get 7 e to the 2x equals 63. So I undid addition subtraction. There's no other addition subtraction. I want to undo multiplication division. Now, even though there's multiplication up here with the 2 and the x, that's all in the exponent, so I can't undo that. But I do have multiplication right there. So we're going to undo that multiplication by 7 with division by 7. So we get e to the 2x equals 9. Okay, so this is where you have a few options. Since this is a base of e, I would personally take the ln, or the natural log of both sides. You could just take the regular log base 10 of both sides if you wanted to. Or if you wanted to then convert this into an exponential with a base of e, you could do that also. So we'll look at 2 ways. The one way is if you take the natural log of both sides. Remember, once you take the natural log of both sides, this exponent can now move in front. So this becomes 2x times ln of e equals ln of 9. The reason I would take the natural log in this case is because, remember, ln is log base e. So this would be saying log base e of e. So whenever we have the same base as what's in the parentheses, it's equal to 1. Okay, so this would become 1, and I just get 2x times 1, which is just 2x. And on the right side, I just have ln of 9. And then to get the x totally by itself, because the x isn't quite by itself yet, what would we have to do? Divide by 2. So, if we're going to look at the calculator answer, we would do ln of 9, natural log of 9, divided by 2, which is about 1.099. Also, remember, it does say that you want to leave the solution set answer. So the solution set answer is what you're typing into the calculator. We typed into the calculator ln of 9 divided by 2. And remember, we put them in those braces, the solution set braces. So that's one way you could have done that problem. You could have also, again, if you don't want to write these other ways down, if it's just going to confuse you, you don't have to, but just know there are other ways to do it. If you wanted to do it this way, if you wanted to convert this into a log now, it would be log base e. So again, we're doing base answer exponent. Our answer is 9, and the exponent is 2x. So you can do that. We still have to do what to get the x by itself, though? We still have to divide that whole thing by 2. So then the solution set would be log base e, which is really ln of 9 divided by 2, which if you look, that was the same thing we got. And then you can type that in your calculator, you get the same thing. If you didn't realize log base e is ln, can you still type log base e in your calculator? You can, because you would just go math, log base, you can put e to the first in here, you would have to put the first in there, and then ln of, what was that, 9, and then divide the whole thing by 2. You get the same answer, okay? So you got a lot of options, or you could just take the regular log of both sides as well. All right, we'll do one more example here, then I'll have you try number 2. So for number 1, we have 4e to the 7x equals 10,273. Sorry, 10,273. All right, so again, first thing we're always doing is we're isolating that base and the exponent by PEMDAS backwards. Is there any addition, subtraction for us to undo? No. There is multiplication though. That 4 needs to be divided. So 10,273 divided by 4. I'm just going to leave it as 10,273 divided by 4 for right now. Because otherwise you're going to get decimal. So it's just easier to leave it in this form, fraction form. All right, now, since we have our base and our exponent isolated, again, I would take the ln of both sides, but that's not your only option, just because it is a base of e. So I would take the natural log of both sides. That would move our exponent out in front. So we get 7x times ln of e. And then we get ln of 10,273 divided by 4. Again, once you have that x in the exponent, we just take the natural log of both sides. All right, so ln of e, remember, is what's going to cancel out. It's going to equal 1. So we just get 7x times 1, which is just 7x. And then we end up with ln of 10,273 divided by 4. And then we divide that whole thing by 7. So our solution set is this. It's kind of ugly looking, but that is our solution set. ln of 10,273 divided by 4. And then we're dividing that whole thing by 7. So you just have to be careful when you're typing that in. It is nice to use those fraction templates on your calculator. So alpha y equals, if you press number 1 from there, and then you can just type it in as you see it, ln, and then within that we're going to have another fraction. So 10,273, on the bottom we're having 4, we close the parentheses, and then on the bottom we have 7. And we get 1.122. All right, take about 3 minutes, try number 2, see where we're at.
What was I saying? My dressing room was slow, but I got it afterwards while I wearing heels.
All right, it looks like most of you have done a pretty good job. Let's just kind of quickly go over this. So again, first thing we're doing is PEMDAS backwards. So we're undoing any addition, subtraction. We're going to add 7. I always get in the habit, if there is something in the exponent, I put that whole exponent in parentheses. Okay, it's just a good habit to get into. Okay, then we take the natural log of both sides, because it is an ln as our base. That is going to move our exponent out in front. So 4x minus 5 times ln of e equals ln of 11,250. Again, also in the book, they don't have those parentheses around. I think it's always a good idea to put parentheses around what you're taking the log or the natural log of. Remember, ln of e is equal to 1. So we are left with just 4x minus 5 here. And now we just have to undo this. So we would add 5. But notice how we already took the log here. So we'd be taking ln of 11,250, close the parentheses, put a plus 5 on the outside. Because we already took the natural log above here. We took the natural log of 11,250. And then we would divide the whole thing by 4. So our solution set is ln of 11,250 plus 5, all divided by 4. And then when you type that in your calculator, you get about 3.582. Okay, questions on that at all? All right, so we're going to spend a few minutes, or we're going to work right now on 23 to 39 on page 514.